In this video, we're going to learn about perpendicular lines and how to write equations of perpendicular lines. So the first thing you need to know is this symbol right here stands for perpendicular. So when we see that symbol, so it looks like an upside down T, that stands for the word perpendicular. And notice too that there's two right angles on both sides. That's because perpendicular lines, if you think about what they look like, it's two lines that intersect and form right angles. So this little square notation is me representing that there's 90 degrees in each of those four corners, which means that those lines are perpendicular. So about the slopes of perpendicular lines, well, we know that they won't have the same slope because the lines do cross. So their slopes have to be negative reciprocals. So, and I'll explain what that means in a second. So perpendicular lines have negative reciprocal slopes. And what does this mean? So essentially what this means is, oops, let me backtrack here. Undo that. So what this means is the slopes have to get flipped and negated. So you're going to flip and negate the slopes. So for example, if I have a slope of, so let's say that the slope is equal to 2. Well, think about that as really 2 over 1, since 2 divided by 1 is 2. So that means the perpendicular slope, so notice I'm writing slope, or the m with a subscript of the perpendicular symbol, would be flip this, so it would become 1 over 2. So the reciprocal part means flip the fraction, and negate means put a negative. Doesn't matter if the negative goes on top or on the bottom or out in front, it's all equivalent. If I see something like negative 3/4 and I want to flip and negate this, so if this is the original, well, the perpendicular would be flip it, so 4/3. If you negate a negative, it becomes positive. So you should always have one positive and one negative. So if we look at this first example here, and it talks about determining whether or not the lines are perpendicular, well, we have to know, do they have flipped and negated slopes? So that's what I'm going to do. So I'm going to go ahead and I'm going to calculate the slope. So remember, our slope formula is the change in y over change in x's, or y2 minus y1 over x2 minus x1. So I'm going to be careful about my notation here. So I'm trying to find the slope of AB. So I'm putting AB as a subscript. And I'm going to subtract the y values, so 9 minus 5. And then I'm going to subtract the x values on the bottom in the same order, so 3 minus 1. So I get 4 over 2, which reduces down to 2. I'm going to do the same thing, but for CD. So for CD, I'm going to subtract the y values, so 6 minus 2. Subtract the x values, 4 minus 2. This is going to give me 4 over 2, which again reduces down to 2. So these lines are parallel because the slopes are the same. They are not perpendicular because my slopes are not flipped and negated, or they are not negative reciprocals. So we don't need to talk about the lines being parallel. We just need to say that they are not perpendicular. So I'm going to say AB is not perpendicular to CD. So watch how I do this. I take the perpendicular symbol and I'm going to put a line through it, which means not perpendicular. So AB is not perpendicular to CD because their slopes are not negative reciprocals. And when you explain, you want to use the term negative reciprocals versus flip and negate. We think about it as flip and negate, but we use the term negative reciprocals. So number 2 and 3 are just like what we did with parallel lines, but now the only difference is we're going to write an equation with perpendicular lines. So our goal is to write an equation that passes through this point, so we know the point, and it has to be perpendicular to this equation. So the perpendicular is going to tell us that we have to use negative reciprocal slopes. So what that means is I'm going to first find my slope. So the slope of the original, so this is already in y equals mx plus b form, so the slope of the original is -2, so that means the perpendicular slope, so remember that's really like -2/1, means we're going to flip that, so 1/2, and negate it. So the negative times the negative means it's going to become positive. So this is the slope of my new line, the +1/2. So now that I know the slope, and we know the point, so now that we know these two things, we can always write the equation of a line. Remember, you always have to know the slope, and as long as you know a point, well, then we can use our point-slope form. So now I'm going to write my equation by doing y minus y1 equals m times x minus x1, well, just like what we saw with the parallel lines. Now I'm going to plug these two things in. Be careful, make sure that you're using the perpendicular slope, not the original slope. So I plug in my point, so this is the x1, y1. So I have y minus 3 equals 1/2 times x minus 2. This is an acceptable answer in point-slope form. If I want to finalize that, I can distribute the 1/2 and bring that 3 over. So -1 plus 3 is going to give me +2. So this would be another answer in y equals mx plus b form, or slope-intercept form. So if I want to do this one graphically, instead of doing the algebraic approach, what I would do is I would graph this original line. So this original line has a slope of, so let me just kind of write this off to the side. So if I have y equals -2x minus 5, I'm starting at a y-intercept of -5. That's the b value. The slope is -2/1, which really means down to right 1. So we're going to start at -5. So 1, 2, 3, 4, 5. And then we're going to go down to right 1, down to right 1, and we're going to backtrack until we filled out the entire graph to represent that this line goes on forever. I'm going to go ahead and connect this. That looks pretty good. Little off, but let's see if I can move it just a tad. I'm going to just leave it because I'm afraid to mess with it too much. So there's my line. And then now I want a line that's going to be perpendicular to this green line that passes through the point 2, 3. So I'm going to go over to 2, up 3. I need to pass through this point and be perpendicular. So we should expect to see kind of a plus sign, right? We should see those right angles formed. So what's going to happen is the perpendicular slope that I need to count, remember we said is 1/2, which really means positive, positive. So we're going up to positive numbers and right to the positive numbers. So from here, we're going to go up 1, right 2, up 1, right 2, and so on. And then backtrack until we cross here. And this is looking pretty good. It's looking as if I have a plus sign, right? Or I have those right angles formed. So I'm going to, again, attempt to connect this using a straight edge. And that's a little bit off this time, a little bit more so than the last one. There we go. And I'm going to label this. So the equation of this line, well, we know the slope is 1/2, so it'll be 1/2 x. The y-intercept is right here at +2, so it's going to be +2, which is exactly what I found using my algebra. So either way, again, algebraically using the graph, the downfall of the graph is if your y-intercept doesn't cross at a nice whole number or a negative number, then we'll have issues because then we won't be able to find it. Then you'll have to do it algebraically. So I always like to do it algebraically unless I already have some stuff on the graph. So for this next one, I'm only going to do it algebraically, just looking at time here. And let's just go through the same process. So if you're feeling pretty confident at this point, pause the video and try it, and then just hit play and watch and see if we get the same thing. So we're going to write the equation of the line that has to pass through this point, and it's going to be perpendicular to this equation here. So starting with this equation, again, the first step is always to find the slope. So I need to get this equation into y equals mx plus b form. Never attempt to find the slope before your equation is in y equals mx plus b form. So I divided everything by 3 to get y by itself, and you can see that I just simplified. Remember that the number in front of x here is a 1, so that's how I'm getting the 1/3, and then 15 over 3 reduced down to 5. So the slope of the original here is 1/3, much different than saying 1, so that's why it's so important that you get y by itself and it's in y equals mx plus b form so you can see the slope. So the slope is 1/3. That tells me that the perpendicular slope, so flip it, it becomes 3 over 1. Negate it becomes negative. So really just -3 is how I can think about it. And now when I write the equation, so I have my formula. So y minus y1 equals m times x minus x1. Here's my point. So we have y minus 5 equals -3. Make sure that you're using the correct slope. So -3, and then x minus x1, which is 1. This is the answer in point slope form. I'm just going to put arrows on there to represent that I plugged in. So point slope form equation, if I want it in slope intercept form, I have to simplify this and get y by itself. So distribute the -3. And then from here, bring that 5 over, so plus 5. So it'll leave me with +3 plus 5, so +8. So slope-intercept form, y equals mx plus b form, versus point slope form. Either are acceptable. If the question doesn't specify, you can leave it however you'd like. So with that, again, I'm going to skip the graph for this one. It's the same process that we've seen. You definitely want to be able to do these algebraically in case you run into some situations where you can't find the y-intercept graphically. So that's why I think it's best to just practice this and then use the graph kind of to check your work. So from here, go ahead and try the check your understanding problems, and then we'll talk about those in class tomorrow.